Hello everyone, in today's video I'm going to be beginning to design a front suspension and steering setup compatible with the FFR SC1 chassis. For those who are unfamiliar with this platform, the FFR SC1 is a 3D printable, small-scale RC car chassis that I designed a little while back and have been since gradually prototyping and tweaking the design in preparation for making the STL files public. We've been spending a lot of time recently getting everything ready for the upcoming release. At this point, it's pretty much just a matter of getting all of the non-3D printable parts in stock and getting some manuals and instructional documentation put together. As you may recall, I designed the chassis in a way that allowed different modular front suspension and steering setups to be easily mounted to the front in an effort to make the chassis as versatile as possible. The current front suspension and steering assembly that I designed and have been utilizing for all projects with this chassis is this assembly here. It's compact to allow space for large motors and utilizes a McPherson strut suspension. I really like this assembly, though it definitely has some shortcomings. The first being the steering, which although is nice and compact, the short arm that the servo connects to doesn't provide much leverage, making it harder for the servo to steer and center. Additionally, this assembly is not capable of providing much steering angle. Although what it does provide is sufficient, it would be nice to have more. Also, having a McPherson strut suspension in this small scale can be a bit finicky. For example, the inner diameter of the outer part of the struts that the rod slides up and down inside needs to be precise so that there is not too much friction, which prevents the rod from sliding easily, but also it is not too loose so that it causes it to bind when pressure is applied, as seen here, preventing it from being able to slide up. Changing springs can help solve this, but it's a little bit of a hassle since it requires a fairly substantial amount of disassembly. This assembly is also quite tall, which could possibly be an issue on certain bodies with lower front ends, along with limiting the amount of backspacing a wheel can have before it comes into contact with the upper strut mount. These are probably the most significant shortcomings of this assembly that I have encountered, along with a number of other builders using this setup. Although it may seem like nitpicking, from an engineering perspective, I want to take some of the shortcomings of this design into account, not only as I continue to improve this particular suspension and steering assembly, but as I begin to develop a new assembly that will hopefully excel in areas that this previous design struggled. Also, a lot of builders are interested in utilizing this chassis for muscle car bodies from the 60s and early 70s. Very few, if any, full-size American cars from this era were using a McPherson strut front suspension. Instead, double A-arm front suspension setups seem to be the most common, so having a suspension that more closely replicates this design would be preferred by many who are building older muscle cars. Another goal for this new suspension design was that I wanted as many parts of it to be FDM 3D printable as possible. I know that making a significant amount of the parts this way would not be too practical, but it's something that I kept in mind throughout the design. After a lot of brainstorming and sketching out some different ideas, I was ready to move into Fusion 360 and begin the CAD process. Today's video is going to focus on the initial design of the front suspension, which will include the crossmember, control arms, and knuckle. The first thing I do is create a new design and import all of the relevant components into it. These include the main chassis piece, motor and motor mount, as well as the steering servo. After adding all of the components and getting everything positioned, I created a sketch plane in the middle of the screw holes to begin sketching the crossmember. As I've said many times before, I think it's always a very good idea to start by creating some design concepts, whether it just be a rough sketch using pencil and paper or something more detailed such as a reference image or blueprints. For me at least, unless it's something very simple and straightforward, I always start by sketching out different ideas that I have and come up with a basic design that I think will work before beginning the design in CAD. I start by positioning these circles in the location of where the control arms will be mounted and sketch the profile that I will later extrude to create that piece. Here I'm really just eyeballing the position of everything and gradually manipulating all of the sketch elements until they are in a location that I am satisfied with. The general geometry of the suspension is something that I kept in mind but wasn't overly concerned about. Going to the levels of detail of what is required when designing a suspension for a full-size vehicle is not something I wanted to get into here, but I did use some measurements and specifications of similar full-size double wishbone suspension setups to determine the approximate location of where certain elements will be. Of course, I can always go back and make adjustments in the future, but for now I just want to keep things simple. The section that I'm working on here is where the top part of the spring will sit. I'll be using the revolve command to create this part later on. I really want to make this part thick to make it as rigid as possible and not require any sort of upper reinforcement like the previous design. What I'm modeling now are some M1.6 washers that will be placed on both sides of the control arm mounts. Here I'm making these sections of the control arm that will be connected to this sort of crossmember and control arm mount piece that I just created. My plan is to mount the control arms using a single M1.6 machine screw with a lock nut on the end. At this point I'm making sure to keep the tolerances relatively loose, or in other words, make sure that there's a decent amount of space between the different parts so that they can easily fit together. This is something I will more than likely adjust after printing out all of the parts and creating the first prototypes. Now I'm moving on to designing the steering knuckle. Unlike the McPherson strut assembly, which used a two-piece knuckle, this assembly will use a more standard single-piece knuckle. Right now I'm designing the center section that will house the two bearings. I'm sketching out the side profile and will then revolve the sketches into solid bodies. After that, I designed the upper and lower ball joints, which will allow the knuckle to be connected to the control arms. I don't want to make the ball joints too large so that they get in the way, but I also don't want to make them too small so that they become too fragile and difficult to print with a high level of dimensional accuracy, which is especially important since they will need to be press fit into the control arms. Once the sketch was complete, I again revolved and extruded elements of the sketch into solid bodies. Here I'm beveling some of the edges just to give it a little nicer appearance. Now I can complete the control arms. I first measure out how far out I want each control arm to extend, and then begin modeling the socket that the knuckle will press fit into. As you can see, I'm once again modeling the side profile, which I will later revolve. Now I can create a sketch plane that is perpendicular, so I can connect the outer socket to the mounts. I sketch a path that I will later turn into a solid pipe. The lower control arm will be very similar to the upper, however, I will need to include a place for the bottom side of the spring to sit. I adjust these new bodies enough so that they extend all of the way inside of each socket and mount, and then I combine all of the bodies. Also, I once again bevel some of the edges just to give it a little nicer appearance. Finally, I adjust the position of the control arms and add a spring just for a quick visualization. And that basically completes the core design of the suspension assembly. Of course, there is still more work to be done and adjustments to be made as the prototyping phase progresses. I also need to figure out a way of mounting it to the chassis. Either I will need to make it so that I can attach using the pre-existing 4 holes, or incorporate some new holes into the chassis piece. In the second part of this video series, I will be showing the design process of the steering system while continuing to refine the front suspension. I hope you enjoyed today's video and it helped give you some ideas and inspiration for your own projects, and any tips or suggestions is always greatly appreciated as I continue to learn more about Fusion and continue to try and utilize it to its full potential. And that is all for today's video. Thank you all very much for watching, and I will see you next time.